Hello, I'm Maria House and I'm part of Team Garfunkel. All children have the ability to learn and gain new skills and experiences that will help them not only in their schooling life but also their daily one. In primary schools, students are taught the essential subjects such as English, maths, and science. However, children are struggling using traditional methods. One such subject is mathematics, due to students being afraid of learning something that looks complex. Maths, however, needs to be taught to children to learn basic skills for them to develop and use further in the future. Mathematics is a broad subject with various topics within it. Therefore, the focus will be on multiplication, an operation children struggle with, however need for other topics. Learning through music can be an educative, engaging, and fun way to teach children skills. This is especially true for maths topics such as multiplication, as it changes how students view the problem because to them it doesn't feel like maths, as they are not learning it the traditional way, or in a way that makes them dread doing it beforehand. Many children love music, therefore musical things and learning go well together. Thus the prototype incorporates music as a remembering tool to help students retain the times tables, a popular way to teach multiplication. All the times tables were used for the prototype, including zero. Teachers use various objects to aid with teaching, including dice, typically in the form of a cube with 6 faces, as children are familiar with this and it is easy to use. However, a typical dice would only allow them to learn timetables from 0 to 5. Therefore, for students to use the dice for all timetables from 0 to 12, there needed to be at least 13 sides. Thus, a 14-sided dice was created. Through this product, students can explore and create sound using the objects they have around them to match the tune of the answer. The interactions with the dice was made easy to use to allow the child to focus on learning their times tables. Thus, how they interact with the dice normally was utilized, as well as providing different and novel ways to create tunes. There are a few parts of the prototype to make it function to some extent. The main sensor is the photon. At the moment, the USB cable still needs to be connected to the laptop to send the data and codes serially from the idle. Though this can be done over Wi-Fi, I was unable to figure out how to write data from Unity to the photon without the cable. This sensor still, however, lights up the neon pixel strips at certain times. For the prototype, 2 strips were required, as both halves of the dice needed each face to light up. For the top, there needed to be 7 RGB lights, and for the bottom, 6. Each RGB light was assigned a number to represent and a certain color. There are 8 RGB lights for each strip. How they are assigned in the code is by using numbers from 0 to 7. 0 is the first RGB light, and 7 is the last. However, how the neon pixel strip was placed and positioned within the dice means that the number 0 is represented by 7, the last light, and so on, with 6 being represented by the second light, 1. Therefore, for example, if a 5 is rolled, then a third light lights up. This is the case for the second strip, however with less RGB lights needed. A 14-sided dice was created using 3D printing to make building the prototype quicker and more solid. Therefore, it would last longer. The dice is able to be opened, with 7 faces to each half. How the dice can be closed is by screwing the dice clockwise for it to lock in, then unscrew by moving it the opposite way. This makes it easier to add and remove sensors within the dice. The size of the dice also allows the current sensors to fit within the prototype and close when the USB cable is not attached to the photon. There are currently image targets on the outside of the dice to allow the web camera to detect which side was rolled. How the image target is detected and tracked is through Vuforia. Developer Portal was used to store the image targets in the database to use in Unity. There are 13 targets all up, each target representing a number 0 to 12. Unity was used as it contains the Vuforia library. Code was then able to be used that allows certain things to happen when the image target is detected, such as writing to the photon which image was detected, for it to then light up the correct corresponding RGB light. At the moment, one script is writing to the photon and being supplied the information from each side's number script. The individual scripts are supplied with information about the status of the image target and when it is true that the image was detected. The corresponding audio will then play. The idea was to have audio for each number to play from the dice. However, this was simulated through using Unity in the computer. This was done because the required sensors were not bought, and how this could be achieved would not be done within the time frame. Though playing this audio was important, the functionality could be clearly shown through using the computer to help users understand the intended purpose of it. The functionality for recording and comparing the sounds created through the interactions with the objects and the stored tunes was simulated as well, and when the user taps the tune with the objects, the sound is manually played by a person clicking play. Objects such as school supplies can be used with a prototype to create the tunes for the answers. They will need 5 objects that is paired with the blocks. They will then use the objects to create the sounds for the corresponding digits that is represented by the colors to answer the multiplication problems with their unique tunes. 5 blocks were created out of balsa wood. The top part of the balsa wood was then colored with permanent markers. These sensors and simulated functionality work together to create a somewhat intended interaction for the user. The musical 14-sided dice provides an alternative method of learning by utilizing music and creating simple interactions. There are a few interactions the user will be required to do to use the prototype. However, many of these interactions repeat, thus the user will learn them quickly. The first interactions are rolling the dice. To pick 2 or more numbers they'll be used as part of the multiplication problem, as the child will need to figure out the answers when they multiply the numbers together. Once the user rolls the number, the corresponding colored light will turn on and the number's tune will play. In this case, the numbers 5 and 9 were rolled, thus the answer is 45. The user unfortunately gets the answer wrong, the first time by tapping the wrong corresponding tunes. Each digit is given a small unique tune based on notes and tonal pitch, thus each number is represented by one or multiple tunes. For the user to get it correct, they must tap the tune for 4 using the corresponding object and then tap the tune for 5. The objects can be whatever the student has with them. They will be given 5 blocks with 2 colors on each, representing 2 digits, as they will both have the same tone or pitch, but different tune and notes. Teachers or parents will need to help the students to know which object produces a similar tone or pitch as the digit's tunes. Before the user answers, they will have to throw the dice in the air for sounds they produce to be recorded and then compared against the sounds stored. In this case, the objects are a pencil, glue, rubber, ruler, and sharpener, based on what children have on them the most at school. As the user got it wrong, a tune that represents the wrong answer being given is played. The user then tries again. This time they got it right. Therefore, the answer's tune will play. Thank you for listening to this video pitch.